Today, the world's population stands at 7.7 billion people. The current estimates suggest that by 2050, this could be nearly 10 billion people. We struggle to feed everybody on planet Earth as it is, so how on earth are we going to feed 10 billion in the future?
All of our food pretty much comes from the soil, and the soil is a resource that we haven't looked after.
Our soil is degrading faster now than at any point in Earth's history.
And we think, for example, in the last 40 years alone, that we've lost a third of the world's agricultural soil to pollution and degradation. If we're going to fix this, we need to do something radically different.
So, how can we grow food without soil? To answer this, scientists and researchers from the University of Sheffield have been working across the globe with alternative technologies and creative ideas, or in some cases, just a pile of old mattresses. A key focus of sustainable food research is looking at how we can overcome the crippling effects of soil degradation. This means looking at how we can take soil out of the equation.
Hydroponics is basically the process of growing food without soil. Because the soil normally gives the plants the nutrients it needs, you need to find another way to give the plants the nutrients.
Harry Wright is a PhD student at the University of Sheffield. His research focuses on the development of polyurethane foams, which can be used for high-value crops for food production. This provides a viable alternative to soil.
The primary purpose of the foam is going to be for the plant's roots to grow in and to hold the plant up.
What is it that makes foam similar to soil in the first place?
The one thing not everyone realizes about soil is soil is actually very porous, so a lot of it is air. Polyurethane foams have quite a lot of similar properties to soil in that regard. If you look at the microscope, all the holes are connected, so there's kind of continuous pathways through the foam which allow the roots to go through, and they also allow water and air to get to the roots.
Part of Harry's research, he's developing the foam so that it more closely resembles the physical, biological and chemical properties of soil.
And then what we've also been doing is we've been adding components that are able to hold the nutrients and hold water within the foam, which is exactly where the plant roots are, so the roots can access the nutrients as they need them. And this also means that we have less wasted nutrients, and we basically optimize the nutrient use of the hydroponic process.
One of the great things about hydroponics is how accessible it is. Even IKEA now sells hydroponics kits that you can use at home.
Because you can do so much in such a small space, it makes it that accessible to sort of everyone. If you live in an apartment, you can still have a little home hydroponic setup.
The development of hydroponic technologies and growing food without soil is just one component of an idea developed at Sheffield called the Microcosm Farm.
Microcosm Farm takes new and existing technologies and it bundles them together in a completely new and exciting way, allowing us to make some of the most sustainable food on the planet. We can make it rain inside using sunshine, we can use sun to power our greenhouses, and we can use alternatives to soil like foams that allow us to grow our plants in a soil-free environment.
Producing enough food for the world's growing population is one of the biggest challenges we face in our future. But for some countries this is already a reality. Countries where it's hot or arid, or where the soil quality is really poor, or where there's a distinct lack of fresh water. Countries like Oman in Western Asia. Like many Middle Eastern countries, Oman sees summer temperatures as high as 50 degrees Celsius. As a result of this, food prices quadruple in the summer months. Our scientists are working with colleagues from Sohar University in Oman to develop a greenhouse full of microcosm farm technologies.
So the projects with Oman and Tinsley basically look to address some of the big problems we have in the world at the moment. That's the use of fresh water for conventional agriculture, which we see as the major user for fresh water. Hydroponics uses 1/10 the water we'd use in conventional agriculture, so that saves a lot on water for a start. And also to deal with the soil degradation issue, we're taking soil out of the equation.
A desalination system converts seawater into fresh water using solar power, and a cooling system helps to combat the stifling summer temperatures in Oman. A hydroponic system also means that crops can be grown without the use of soil.
We're hoping to develop a system that is very much a box system where you can add or remove different components, and then this system could be tailored for any country in the world, where we could theoretically put it in a container, drop it anywhere that needs food production quickly, and we can tailor it to local conditions.
The collaboration in Oman brings together a number of new technologies to help grow food more sustainably. The aim is to ultimately have a drop package greenhouse, which we can put in any country in the world.
However, over 2,000 kilometres away, the impact of microcosm farming is already being felt. In Zaatari, a refugee camp that is home to 80,000 people.
This is at least in part thanks to a stockpile of old, worn-out mattresses.
They took me into a warehouse that contained piles and piles of polyurethane foam mattresses, and they said, we don't know what to do with them. And that was a revelation.
Professor Tony Ryan and his team had already been working with the refugees to produce useful products out of waste materials.
I clambered up and got one down, piece of it here, and we'd been growing plants in polyurethane as a synthetic soil. And then I knew we could make a real difference in the refugee camp to allow people to grow plants for themselves. The Jordanian authorities really don't want the refugees to become permanent, so they won't allow them to plant things in the ground.
Sheffield PhD student Harry has been central to the work in Zaatari. He's helped design and develop the hydroponic system and helped the refugees to implement it.
The Zaatari refugees applied their years of farming knowledge to the principles of hydroponics, and soon after, the system began to work. Across the camp, more than 200 refugees have been trained to use this waste material as an alternative to soil, and they already have an area the size of a tennis court covered in these systems.
Obviously, it's a very distressing situation being in a refugee camp, especially if you've come from a beautiful, fertile farmland. So people's mental health is really helped by being able to grow things.
The work of Sheffield researchers to develop new approaches to the problems of food production are already having a massive impact around the world. But the technology is also being applied much closer to home. This former primary school in Tinsley has been converted into an urban farm, complete with its own hydroponic system.
We're looking at a very big production shortfall, and we need to be addressing ways to be growing food for our population that aren't conventional agriculture. And here we can help with that problem, but we can also look at attacking some of the environmental issues, such as reducing water usage and soil usage.
The farm is also expected to be used as a form of outreach, providing training for local workers as well as an educational environment for schools in Sheffield.
We see here a physical manifestation of some of the work that happens at the University of Sheffield. Rather than speaking about it and publishing papers, we've actually built the system and engaging with the local community.
The challenge to feed 10 billion by 2050 is vast and complex, and though Microcosm Farm might not provide all the answers, it is already helping to feed people around the world.
Microcosm Farm isn't going to produce food for everybody on planet Earth, but it's going to take a lot of pressure off existing agricultural systems. And because it's so efficient, it means we can do that using a lot less resources. In the future, I hope we can see microcosm farms all over the world, optimised for local conditions, producing cheap, healthy and sustainable food for the global population.
If you enjoyed this film and want to find out more about our research, then follow the links in the description below. I'd just like to give a huge thanks to Tony, Duncan, Harry and Jacob for their contributions, and to everyone else who made this film possible. Don't forget to subscribe to our channel for more videos like this one.